Okay, so we did not finish all of 2.8 last time, so now we're going to finish up with some more information about derivatives. So we know that we have this relationship between the velocity and the derivative, and the velocity tells you how fast an object is moving, and it also tells you in what direction. So usually when we talk about velocity in calculus, we're talking about a one-dimensional, so movement in one dimension, because we don't want to deal with functions in more than one dimension. So in the one-dimensional case, what we can say, if we know the velocity of a function, is whether it's moving forwards or backwards or up and down, depending on how we're measuring the movement of whatever object we're interested in. The derivative is sort of like a generalization of the idea of velocity, and the derivative tells you how fast the function is changing, whichever function you're looking at, and it tells you whether it's increasing or decreasing. So that's the same idea of like velocity telling you what direction it's moving in. So here, with just a general function, we get information about whether the function is increasing or decreasing. So what happens is let me grab a pen. So if f prime, the derivative of a function, is positive, this means that f is increasing. And if f is increasing, so I'm going to, if f is increasing, f prime is also positive. So when I write this, I may have mentioned this before, but it doesn't hurt to mention it again. When I write this double-sided arrow with two bars like that, this means if and only if. Okay, so it's saying that if we know that f prime is positive, then we know it's increasing, and also if we know that f is increasing, then we know that the derivative f prime is positive. Okay, so it goes both ways. Okay, similarly, if f prime is negative, then that means that the function is decreasing, and if the function is decreasing, that means that the derivative is negative. Okay? If f prime is 0, so equal to 0, that means that the function itself is flat. So what I mean by that is that it has a horizontal tangent. Now, it's not really flat in the sense that you might think it would be, because this is happening at a particular point. So when I say when I say flat at a point, I mean that it has a horizontal tangent. So just to jump ahead, so in this example we have right here, this point at the top, it has a horizontal tangent there. So it's flat for just a second, just at that one point, but since when we're talking about the derivative, we're talking about behavior at that point. That's what I mean. So maybe it's easier for you to think of horizontal tangent, but I like to say it's flat at that point. And then also the steeper the function is, the larger the magnitude of f prime. Okay, so we're going to use these statements that we've made about the relationship between a function and its derivative to actually graph the derivative from the graph of a function. So here I have two examples, and I have them split right here. Okay, so here's example one. So here, this top graph is the function, and the bottom graph is the derivative. And the same goes in example two. So the top graph is the function, bottom graph is the derivative. So just looking at this function right here, I've already noted that it's flat at 1. So at x equals 1, we have a horizontal tangent. And so what that means, according to these facts that we've written down, is that the derivative is equal to 0. And so if we look down here, we can see that yes, the derivative actually touches the x-axis, so that means that f prime of 1 is equal to 0 at that point, right? Okay, now let's focus on this portion from 0 to 1 of this function. And we see that on that whole interval, and it looks like it even continues down that way, the function is increasing. So moving from left to right, the function values are getting larger and larger, so the function is increasing on that interval. Okay, and so we know from up here, if the function is increasing, that means that the derivative is positive. So looking down here at our derivative graph, we see that on that same interval from, well, up to 1, we see that the derivative, the graph lies above the x-axis. That means that it is above the x-axis, which means that f prime is positive, 0 on this part. And when I say this part, I mean this interval that we're talking about. And then on the other hand, if we look at the interval from 1 to 2, let's say, the function is decreasing on that part, and then we also see that on the graph of our derivative that this is beneath the x-axis, meaning that f prime is negative on, we'll assume that this function is defined on the whole real line, and then so it's negative for all values greater than 1, right? Okay, so we can see that this is how the graph of the function and the graph of the derivative are related. Okay. Here in this second example, this is a little bit more involved. So we have the graph of this function, and looking at just anywhere it has a horizontal tangent, we have a lump right here. So the top of that is going to be a point where we have a horizontal tangent, and also we have this sort of flat part right here at 0, and so we actually get a horizontal tangent there as well. Okay, so these are our two places where we know that f prime should be 0. And so if we look down at the derivative, the graph of the derivative, we see that it touches the x-axis at 0, so that's one of our horizontal tangents, and then it also touches the x-axis at that point where we noted there was another horizontal tangent. So this is, right, so far we have everything lines up. Okay, now we want to look at increasing or decreasing, so the intervals on which this function is increasing or decreasing. So if we look at this graph, we see that from here, so when the graph starts, all the way over to this point where we have our horizontal tangent, it looks like it's about 0.75, the graph is decreasing on that whole piece. But we know that it actually is equal to 0 at 0, the derivative. So what happens is the function or the derivative, sorry, let me label these so it's clear. So the derivative is negative on this whole piece, but it touches 0 at 0. So it comes up to touch 0, and then it stays below the axis because the function is still decreasing. And then once it hits this point right here, we see that the function is increasing, and so the derivative crosses from beneath the x-axis to above the x-axis and becomes positive. Okay, so sometimes it's nice to draw like a number line beneath the graph and just note that we have these points where this is flat, and then I'm going to note on the intervals that this is decreasing here, decreasing from 0 to 0.75, and then afterwards increasing. Right? And so we see that the derivative is going to then be 0 at this point, 0 at 0.75, and then it is positive on this piece, right? And then negative on the other two intervals. Okay, so this is basically, we're just creating a number line and then like writing down the behavior of f on the number line, and then here we're writing down the behavior of f prime on the number line. And doing this will help you sometimes with the graphing, because here we were already given the answers, but next we're going to actually find the graph of the derivative by just having the graph of f and using these facts that we talked about. Okay, so we will do that in the next video.